Hello. Shall we continue now?
Hello, okay, yeah. Hello.
So let's continue.
Okay.
And MIMO, massive MIMO, now is one of the key technologies of 5G. MIMO can improve the throughput, and but sometimes the MIMO is, I have said, the MIMO technology is sometimes is very objective. Sometimes is not very easy to understand. But sometimes for us, for Huawei engineer, for Huawei's instructor, sometimes can't describe this technology is very clearly. And so we can say that this is a small video can help us. What's the MIMO and what's the performing, and so on. Maybe can help us understand well. Next, we will learn the high spectral efficiency. Please.
Yeah, I have one question about how many antenna is deployed in this current version of 5G. How many antenna is deployed practically?
How many antenna? You mean antenna is logical antenna or hardware antenna?
Hardware antenna.
Hardware.
Yeah, I mean 64T, 64R is deployed now in 5G.
Yes. And compared with 4G, the 5G antenna is small, but is widely is 4G, and is 5G. Now in China, we have in our lab there is also have there also a 5G antenna, and the 5G antenna is smaller than the 4G, but it's widely, it's wide, and actually the 5G uses the high frequency, and it needs more antenna, more base station for coverage. Maybe one antenna just can cover several hundred meters. 200 to 300 to 500 meters. So this is a situation.
Is there any plan to increase the number of antenna in future in 5G?
What's antenna?
Increase number of antenna to more than 64 antenna in future scenarios.
You mean maybe in the future the 4G antenna, 5G antenna, and the 3G antenna integrated in one antenna?
No. I mean for 5G antenna.
Yeah.
You said now 64 antenna is deployed in base station, for example, in China, in your country.
Yeah.
Is it practically 64 antenna is used? Is there plan to increase this number for future scenarios?
Yeah. Yes. You mean this? What's you mean in the future?
Next, for example, next release.
Next release, next version.
Yeah.
Maybe 128.
Yeah. I mean.
You mean this one? Maybe.
Yeah.
Maybe now it's just the 16.4 this one. Maybe in the future you use this one.
Okay, thank you very much.
Okay. Sorry, sir, can I ask a question, please?
please.
Just now you mentioned there's a logical antenna. Could you please explain what do you mean by logical antenna?
Logical antenna means this is a hardware antenna, and the logical antenna. This is a logical antenna. This is logical antenna, and in one hardware, in this hardware, there are 16 port. 1, 2, 3, 4, 5, 6, 7, 8. Totally 16 port antenna. This is logical antenna. Just in one hardware antenna. Clearly?
Okay, thank you very much.
Like this one, this is a logical antenna. Next, channel coding. Channel coding. And about the channel coding in 5G, we also introduced two new coding methods, which are LDPC and Polo code. Polo code. In our 3G and 4G, with turbo coding is used. This one is used. Turbo coding used. Turbo coding used. But the turbo coding is good at that time 3G and 4G. Turbo code. Turbo code. But for 5G, we want to have much more data, much more speed. The turbo code is not suitable any longer. And for the user play, LDPC is used for user play. For eMBB scenarios, use LDPC code. And for user play, user control channel use Polo code. Polo code is better for low speed. Now we can say low speed performance. Polo code is good. For high speed efficiency, Polo code. For high speed performance, LDPC and turbo. And for high speed efficiency, LDPC. So now the 3GPP defined these two channel code be used. LDPC for eMBB, Polo code for control plane, for control signal. And for OFDM, F means the filter. OFDM used just the LTE. And for FDM, for OFDM, F means filter, is used in 5G. And compared with OFDM, OFDM has a high efficiency. We can see this picture. Because the 5G air interface introduced a better filtering technology. So the guidance band require and improve the efficiency utilization. This is 5G. It's more. It has a much better performance. And the curve is much sharper. Compared with the OFDM, OMDM, and the LTE just have 10 garden band, 10% garden band. But for F, for our 5G, just only have less than 10% garden band. And in our LTE, for example, the bandwidth 20 megahertz, 20 megahertz. In our 20 megahertz, or 20 megahertz, and just have the really used for bandwidth is 18 megahertz. We can 18 megahertz. We can make a small calculation. In our LT, one subcarrier is 15 kilohertz, and multiple 1 RB, video resource block, 1 RB has 12 subcarriers, and in our 20 megahertz, this bandwidth have 100 RB, 100 RB. So equal to megahertz, 18 megahertz, and the other 2 megahertz are used in guard band. So the efficiency just have 19, the efficiency. But for our 5G, it uses the filtering technology, and it has a good performance. For example, if the subcarrier space, we use the 13, and the subcarrier 30, we also make a subcarrier, also make a small calculation, and subcarrier and kilohertz, and multiple 1 5G subcarrier has also have the 12, and 3GPP defined E1 megahertz has 135 RB, 35 RB, and maybe equal to megahertz. So the efficiency is good. The efficiency is good. Then the 5G, the 4G. This is the efficiency.
Excuse me?
Please.
Yes. You mentioned that OFDM is used in LTE, and then you said if OFDM is used in 5G. So what about this one in the middle, WOFDM? Which generation is used OFDM? The WOFDM, sorry.
This one.
Yes, this one.
FOW. You mean what's the WOFDM?
Yes.
Maybe I want another OFDM or tech.
Please. Sorry. Can I answer? information about that?
Uh-huh.
So the WOFDM just means windowing OFDM. So you can just use specific or dedicate some band for OFDM, just windowing in time domain. So you have a bigger than OFDM bandwidth. Not used in any type of communication.
Okay, thank you.
Okay.
In 4G, using OFDM for uplink, downlink, and using single channel OFDM for uplink.
Mm-hmm. Perfect. Thank you very much. Thanks.
Okay.
Excuse
thank
me.
you.
Excuse me.
Please.
The filter type, generally we have two types of filters in digital communication systems in general. The first one is called race cosine filtering, which is used in 3G, 2G, and the previous generations. But for the 4G, the filter type is called Hcia filter, much sharper than race cosine filtering. Yes.
Mm-hmm. So sorry, I can't get your point. You mean? Can you repeat your question?
Yes, I just explained the type of the filter which is used in 4G. It's called Hcia filtering. Hcia.
Filter.
Yes.
Filter.
It's called Hcia, the type of the filter. But in 3G, 2G, and the previous generations, the filter is called race cosine filter. It's based on hand window. It's called hand window.
Mm-hmm. For hand
Yes.
window?
Windowing. This is just an explanation.
Sorry. Window. You mean 3G, 2G, 3G, and 4G also use the filter?
Yes, of course, there is filter. Without filtering, you cannot transmit signals because digital communication systems uses binary digits. They have a lot of spectral side lobes. So we have to use filtering in digital communication. It's a must, and we have to use it. But the type of the filter is different. The type of the filter is different. Yes.
Oh, use a different filter. But
yes, the filter itself is different. Always we have filtering in communication systems.
Yeah. This technology filter is used in our communication technology. But maybe in our 5G, the filter, the hardware is better. It's good performance.
Yes. The filter is a new technology of filtering.
Yeah.
Please just.
Please.
I think answer was this filter is in processor, not just after we complete the OFDM block. When we change from serial to parallel and take inverse f of t, then added the cyclic prefix, then transmit in the last one using filter. But in this technique, the filter is embedded in the OFDM block in the processors.
Yes, I know. It's the filtering is done in the baseband, not in the RF stage.
Yes.
Thank you.
Okay. Next, the numerage. On the air interface, we have also very flexible spacing of the subcarrier. the subcarrier can be from 15 kilohertz, 13 kilohertz, 16 kilohertz, even 120 kilohertz. You know, our LTE just supports one subcarrier space, 15 kilohertz, 15 kilohertz. And the broaden the subcarrier is, and then the less the time domain interval is TTI. The TTI means the transmission times interval. When we are using 15 kilohertz, for the subcarrier, the TTI is 1 millisecond. The TTI is 1 millisecond. Why we are use 13 kilohertz, we for the subcarrier, the transmission interval is 0.5 millisecond. When we use this one, the TTI is short. Using different bandwidths for the subcarrier, they have different transmission interval. For 5G, it can adapt to different service. Of course, you know, the less the TTI is, the more it has a more responding quickly speed for responding. You know, in some URLLC service, if the TTI is short, means it is better. We can make sure the low latency can make can provide the good URLLC service. So this is the one advantage that compared with our 4G. And last one is the self-contented slot. Also for low latency. This is for URLLC service. In fact, it's not realized yet because this has a very high requirement for the user equipment for the mobile. But let's know this concept. The self-contented time slots means each time slot has uplink and downlink in one slot, downlink and uplink information both. Like in LTE, you know, or 4G, the time slot can be only uplink slots and downlink slots. You know, or LTE. One slot uplink, one slot downlink. But for our 5G, self-contented slot, one slot can have downlink and uplink at the same time. So for in this case, the responding speed can be mastered faster because uplink and downlink almost happened at the same moment. This is the usage for the self-contained slot. Maybe in the future, URLLC service may use this technique. Self-contained slot, to short the purpose is to shorten the RTT delay of uplink and downlink data transmission. This is a self-contented slot. Okay, I make a short summary. This class, we have learned some 5G technology from the core network. core network. Include CUPS, as core network, CUPS, and SBA, and slice, and slicing, and cloud native. This is cloud native, cloud native, for or IP transmission, IP build, like L3 to H, EDGE, and slice, the Flex-E, Flex-E, and for RAN, have the DRAN, CRAN, and Cloud RAN, And for air interface, we learn the massive MIMO, FDM, and uplink and downlink decoupling, and the numeric, and the CUDU separation, and so on. This is we have learned in the second materials, and we can make some small quiz, help us digest the content. Okay, the first one. URLLC can be supported by NSA mode. This is true or false?
True.
True or false?
True.
Yeah, the right answer is true. URLC can't be supported by NSA mode. NSA mode just support EMBB scenarios. And second, sub 6G hertz include sub 3G hertz and C band.
True.
True or false?
True.
Okay, yeah, right. The answer is true. The third, what channel coding method is adopted on control channel of 5G air interface?
A.
Polar.
No, D.
A.
Polar. D.
Polar.
Polar.
MBB, LDC, LDPC.
Polar. D.
LDBC, because the four
A.
follow.
The first one is for user plane and the D for control plane.
The first one is for data.
The right answer is polo code. Yeah, and LDPC use the
Data control.
EMBB data channel, and this is a polo code. Polo code used in control signal. Okay, the first, which ones of the below techniques can be used to solve
Which one is correct?
D. This one is D.
D is correct.
Clearly? LDPC used for EMBB.
Yeah.
Okay, thanks.
Okay, the first, which ones of the below techniques can be used to solve the uplink and downlink imbalance problem?
A and B.
This is a multiple choice.
Yeah, multiple
So
choice.
A and B.
A and B maybe.
And C.
A and C.
A and B.
A and C.
A and C.
A and B.
A and B.
Yeah, the right answer is A and B. I think A is no problem. The uplink and downlink is copy SUL. And the dual connection, actually dual connection means multiple MSA. MSA actually is MSA, multiple string aggregation. You know, in OSA, NSA networking, 5G new NR is a data split. It will be NR base station will cooperated with the 4G base station and provide data service for the UE. So the right answer is A and B. And the last one, multiple choice. Which ones of the below 5G core network function belong to control plane?
D.
Multiple choice.
Multiple choice, yeah.
A
and D.
A and D.
A.
Would be policy control, maybe D.
C.
A and C.
A.
C,
C, B, D.
C, D. Except B. I, C, D.
User plane control.
All of
Except
them
user
are considered as a control plane.
And C. A, C, D.
Yeah, perfect.
Yeah, well, the short answer A and D.
Because B is user plane.
Yeah, the right answer is A, C, D. Yes, B is for user plane. Yes, right. I think most of you have know about this knowledge. Okay, and the second material is over. Have any question?
Yes, please, just one question.
Oh, please.
Can I ask one question?
Please.
Yes, you don't mention anything about frequency planning. So 5G is the same as 3G and 4G using reduced frequency 1. So there is no frequency division as we see in GSM when divided the cell to different sub-frequency band. So the all base station using the same frequencies available in one cell. This is one question. And it is right?
You mean 2G and 5G use the same frequency?
No. We in 2G,
yeah,
GSM, we divided this the base station, so the cell, to several subband, F12, 21 different sub frequency. But in 3G and 4G, the frequency, reuse frequency is 1. So all cells using the same frequency to increase the bandwidth for users. All users can benefit from the all bandwidth provided by the operator. So the frequency reuse is 1. Is it right?
The last sentence, last one I didn't clear, listen clear.
In 5G, we don't have reuse frequency. Reuse frequency equal 1. Is right?
Yeah. Yes.
This is one. Another thing, if we have some problem or some interference in one cell, there is technique using fractional frequency reuse. Do you have any information about this technique using in 5G? Fractional frequency?
No. But I can, after class, I can find some materials.
Thank you.
Okay. After class, I find some materials and I try my best. Okay. Next, we start our third material. 5G use case. 5G use case. Our 5G focus on the vertical industry. We say that 5G change our life, and 4G change our life, and 5G change our society. And the 4G focus on the connection between the people and the people, and the 5G focus on the people to machine, focus on the connection people and the machine to machine, and how 5G enable the vertical industry. We can see this material, and objectives. Upon completion of this course, you will be able to describe the progress of 5G service, describe the business application of 5G 5G industry, can describe the development of step of 5G service. Let's see the first part. And we can see this picture. Let's see this picture. And GSMA official prediction by 2025 may they have 1-2 billion 5G connection. And it predicts that by the year 2025. Let's see this chart. By this year, the 5G will occupy around the 15 of the mobile market, and the connection will be 1.4 billion users. This will only around 5 years. So we see that the 5G will develop very fast. And there is another organization, IHS. This one. IHS. It also has a prediction about the economic activities in the year 2025. 13.5, a bit longer, and there will be 12 trillion global economical activities. Among of these are distributed in different industries. We can see that the biggest share is manufacturing. The biggest share is manufacturing. Manufacturing. This one, it has 3,300 million of the economical activities. And so all of these kinds of service in different industry will be provided in 3 scenarios. We have been very familiar of these three scenarios. One is enhanced mobile broadband, and URLLC, and MMTC. So these are huge number of money in the future, around 20 years. This is a situation about our 5G's future. And one concept was issued that is 5G AAP. 5G as a plentiful means 5G as a plentiful. 5G will be a plentiful. 5G can act as a plentiful for the customer, for the industry, and is a flat plentiful for the operator and the carrier. The customer can get a lot of service types from the network, which can't from the 4G, even 3G. And for example, the AR VR, this is for customer, for the end customer. And for different industry or business customers, they may have their network slice for the individual purpose in need for their individual usage. For example, the electricity power supply company, they need one slice for the network as subnet, like our nation grid. It's need the sub network must be reliable, must stable, must be stable. So we see that the 5G can provide this capability to the vertical industry. And 5G brings new business opportunities. Let's have brief views about our 3G and 4G. 3G focuses on the voice and short message. This is the mobile internet. And in 3G, maybe 20 years ago, at that time we just had a smartphone. The new comes our life, and this is the new service introduced by 3G. In 3G we just can set a small picture, just can see the website, but the speed is also very slowly, and there are no much people to access the internet by the mobile terminal. We often access internet by our computer. But our 4G, the human beings enter the mobile era. The 4G just not only can not only support the voice, show the message, and we can also support very kinds of OTT service like serial views, serial videos, and so on and so on. And 5G, what can 5G do? Like not only show the message, voice, mobile internet, like FWA. FWA means the physical physics wireless access. Wireless physical wireless physics access, and it can support IoT, means the Internet of Things, like NB-IoT, MFTC, used in our smart park, used in the intelligent meter reading, like used in shared bicycle. This is all 5G can support. And URLLC, like V2X, like the remote health care, remote surgeon, and so on and so on. This is all 5G can do. 5G can do. Like smart health care, smart manufacturing, automatic driving, smart grid, EMBB. This is the first part. Okay, let's have a short break. 10 minutes.
Okay.
Yeah, that's fine.
Okay.